Hi everyone, thank you for joining. My name is Katz. I'm an algorithm engineer from Taboola. Today we are going to talk about enabling the next OpenAI, bridging the gap between academia and industry. Let's start. First of all, a teaser. OpenAI, the company we are all familiar with, started as a non-profitable research laboratory in San Francisco. After an investment of $1 billion from Microsoft, this is their new office in London. We all drink coffee. I'm sure that they first had a very simple coffee machine, and now they can afford the expensive one. A little bit about Taboola. Taboola is the leading content recommendation company in the world. We supply personalized recommendations for additional reading, articles, and also advertisements. We do it by using a neural network model that extracts the item features. For example, the item is a news article. We use the title and the thumbnail. We use the context features, the time of day, and the operating system, whether you are using a mobile phone or a desktop, and also the user features, your past history and behavior. We're feeding our recommender system model those features, and we predict the probability that a user will click on a certain item given the context. We are also a big data company. We have over 500 million daily active users. We are dealing with 500,000 HTTP requests per second. We have over 3 billion page views per day. We're generating 1 trillion recommendations per month, serving millions of recommendations per day, and we're generating over 100 terabytes of data per day. In this lecture, I want to talk about why industry needs academia and why academia needs industry. Why is the current cooperation not optimal? I will present some successful models that we executed in Taboola with academia. And we are going also to talk about what we can do as industry and individuals in order to make this collaboration better. Let's start. So the example use case, OpenAI. As I said, they started in 2015, non-profitable San Francisco-based research laboratory. 4 years later, Microsoft identified a potential in their product and invest $1 billion. 2 years later, they published DALL-E, and 1 year later, ChatGPT. This year, Microsoft invested additional $10 billion in OpenAI. I'm not sure that you all know this, but all the systems that OpenAI uses are based on Microsoft's products. For example, they use the Azure-based supercomputing platform. The event that is important for us in this pipeline of development is the first initial investment of $1 billion, which accelerated OpenAI's development very quickly. So let's take a look at those two words, the academia and industry, and try to get familiar with their different interests. So about academia, researchers are interested in finding new ideas, pursuing the truth. They want to advance knowledge through research. They're of course interested in publications, and they need grants, they need money. On the other hand, industry are interested in profits, value for their stakeholders, marketable solutions. They want to optimize processes, reduce costs and increase efficiency, and they want to stay competitive on the market. Why academia needs industry? Well, it is obvious that we in industry have real-world applications, we have the practical experience, we have scale, as you all saw, we have major amounts of data, We have the funding and of course our own innovations. I want to talk about data. This is a paper that was recently released in 2022 that describes the available data sets in the field of news recommendations for the academia to use and to base their theories on this data. As we all can see together, there are not so many public data sets out there. For example, here we see only 6. If we will look together on the period column, we will see that the data sets are pretty old. The companies that release them don't update them very often, and they also contain very few weeks of data. Okay, 30 days till 6 weeks. Okay, so this is a problem for a researcher, for example, that want to identify some seasonalities that are longer than few weeks, for example yearly seasonalities, that are not being considered in these data sets at all. Why industry needs academia? So first of all, academia holds the talent pipeline. We hire students that are graduating from academia, and it is best for us to identify those talents earlier before they actually arrive to the market. We also want to use their expertise and innovations. And the most important point, I think, is that the researchers have the capability to use multidisciplinary solutions and to cooperate with each other on a field that we usually don't use. For example, complex solutions from biology or from cognitive sciences, which we in industry use less. So why is the current cooperation not optimal? So different interests lead to different priorities. Regarding intellectual property, the academia wants publications, and we in industry want to stay competitive. We don't want to publish our own innovations so quickly. In addition, in academia, the time frames can be very long, but in industry, we want value for our stakeholders, we want short-term solutions. Lack of resources, time and money, of course, and if there is not an open channel between academia and industry through the entire project, then it can lead to a lack of trust. Last point, and very important one, is the security or privacy issues. Many projects fail before they even start because the academia team, the students, don't have permissions to work on the company data, to run models inside it. And we, as a company, need to prepare public data sets and to encrypt them before giving them to start their research. But nevertheless, together we can achieve mutual goals if we will do it right. And today I'm going to show you how. So the first project that I will describe is a collaboration between DeepLab, which is a research laboratory that gives consultant services to companies. And they have many experts. They are working on virtual screening in drugs discovery. They also have experts in recommender system, in anomaly detection, fraud, cyber, and even stock forecasting. We use the team that specialized in recommender systems. And we published a paper with them on a project that we did that is called an incremental learning framework for large-scale CTR prediction. CTR is click-through rate, and this is basically what we want to do. We want to predict the probability for a click. Today, I'm going to talk about this innovation. Let's start with the challenge. We all can see this user, which probably likes chess, and we want to be able to serve items that are related to chess to this user. But as a news website, we also want that this user will be updated with last events. So we want to serve fresh data in addition to the user preferences. If we will translate this problem into modeling, then we have the training phase and we have the inference phase. When we use the trained model in order to predict what is the probability that this user will click on a new item. The gap between the training and the inference is critical because data in the world is changing, new events arrive, and the accuracy of our model decreases over time. The solution is incremental learning, and we did it by, instead of training our model on the entire data set of 14 days, last 2 weeks, we used warm start technique and created small models that are working on a small fraction of the data set instead of all the entire last 2 weeks, but they use the weights of the base model. This is called the teacher-student paradigm, where the teacher is the heavy model that is trained on the entire data set, but it is trained once a day. And the students are smaller models that are being trained every 4 hours, for example, in Taboola, but they use the weights of the teacher model. In addition to that, we also use a technique called knowledge distillation, which is a manipulation on the loss function. The loss is the function that we use in order to score the accuracy of the model, the difference between the expected and the observed prediction in the world. And knowledge distillation this technique keeps the data, and it is being distilled to the small student model, okay? By using a small manipulation on the loss function of the student model. So, warm start and KD was our solution, and let's take a look at this schema. Here we can see a teacher student T that is being trained on 14 days, and a smaller student model called S1 that is being trained on 4 hours after the teacher student were already trained. It uses the teacher's weights and also the knowledge distillation technique. As you can see, a new event, the green event, arrived. Student 1 is not aware of it and it cannot serve it to the users. But student number 2 that was trained 4 hours later already familiar with the green event, and it will be able to serve it in inference time. And so are the other student models. The project was a success. We can see on the left the lift in RPM, revenue per milli, in orange, when we used warm start and KD techniques. And we also see that the loss, the difference between the observed and the predicted, decreased in this project, which is good. We want to minimize the loss. On the right, we can see the lift, but split it into new, fresh data versus old data in different data sets, campaigns, targets, and sources. In all of them, we got very nice lift in new content, and that's what we wanted to achieve. We wanted to be able to serve fresh data. Another project that we did was a collaboration with the university, and it involved undergraduate students. It is called Starship. We worked with 3rd and 4th year undergraduate students in a university called Ben-Gurion University in Israel. We received the students for 1 semester. They got academic points, and also they achieved this practical experience in data science. The result was a value to Taboola, but of course a value to the students as well, because we published a technical blog post in Taboola blog. They used the blog post, of course, in the resume later and found jobs, the first job, very quickly. The project is anomaly detection using LSTM with autoencoder. In this project, we are talking about a different problem. We can see here a metric. This is the request rate in Taboola. And there is an anomaly, a peak at the middle. Before the anomaly, we can also see a gap, a black gap in the metric. That is a downtime. Taboola, as you already figured, needs to be online 24/7, so a downtime means we crashed. This specific incident is the Kobe Bryant tragedy that happened in 26th of January 2020. In this time, many users read and used the internet, clicked and read the news, wanted to be updated with the tragedy details, and Taboola got enormous amounts of traffic and just crashed. The challenge in this project was to be able not just to predict the anomaly in one metric, but to combine different anomalies from different metrics in order to understand if this is a real scenario or just a noise. So we took a bunch of metrics. We took the request rate, successful and failed. We took the response time, the heap, the memory of our servers, and also the CPU. And we chose the model called LSTM, which is a long short-term memory model. The basic idea is that the output of the previous step is fed as an input to the next step, so it works serially. And we combined this model with another model called autoencoder, because we injected to the model a group of metrics. We wanted to be able to compress this data and extract only the important features from those metrics. And autoencoder enable us to represent the same data that we got as an input, but in a latent representation in order to use it in the model in an optimal way. In addition to the autoencoder, we wanted also to be able to alert when an anomaly happens. So we wanted to be able to cross some threshold before triggering an alert. So we checked multiple thresholds. Here we can see the blue plot is a representation of the real data. The red plot is an exponential mean. You can see the formula of the exponential mean. Basically, it goes with the real data very nicely. We also checked a fixed threshold, the green one, which is not good for us because we have, as you can see in the data, weekly seasonality. All the peaks that you see, the small peaks, are basically weekends. We don't want to alert every weekend. We just want to alert when there is a real scenario. So, and there is also another rolling mean based on the standard deviation in orange that we checked as well. Of course, the chosen threshold was exponential mean, the red one, because it identified the real anomaly quickly. And this project was also a success. We were able to predict downtime 30 minutes before it actually happened. This is a very good project for Taboola for production, and we of course implemented it, and we are still using it. Here is another success. This is a drop in data. Again, we identified 30 minutes before it actually happened. Okay, to summarize, I showed you different challenges, okay? And I want to show you how we dealt with them in both projects. So the first one was different interests, different priorities. So what we did, we just defined two separate goals for academia and one different goal for industry. For example, I take the Deep Lab collaboration. The industry goal was to train the model more frequently in order to be able to serve fresh items. But for the academia, we wanted to be able to present in a recommendation system conference, and we wanted to publish a paper. So the researchers were motivated in this project as well as we did. Free publication versus competitive advantage. So we as a company understood that publication is good and it will not harm our competitiveness. We published in conferences, we published in different research papers and also technical blog posts. Different time frames. So in order to be able to monitor the development, we broke the problem into several steps. For example, in Deep Lab, developing warm start, then developing the KD, evaluating KD, and only then combining both techniques together. In the Starship, same breakdown, first LSTM, then adding the autoencoder, and finally doing an exponential mean threshold. This breakdown was good for us and also for the developers. The research teams, because they were able to have a well-defined checklist and to understand where they are in every step of the way. Lack of resources. We defined an ETA to each project, and we held a very open communication channel between us and academia. We had daily and weekly statuses, and with the students, the undergraduate students, we met twice a week. And regarding security and privacy issues, well, the Deep Lab collaboration was very simple because we hired the researchers as Taboola contractors, so they have all the permissions, and they were able to get access to the data and also to run models in production and experiments. And regarding the students, we created external data sets, we encrypted it and gave them for their use. Back to us. So how do we encourage more successful collaborations? Two words: be proactive. What can we as industry do to improve this collaboration and cooperation? First of all, join meetups with academia. Second, host internships, mentoring, mentor students, participate in research. Remember, we have the data, they want the data. Support grants. Don't be afraid to support research. It means to invest an initial relatively big amount of money. Remember OpenAI and their first investment? That's how this innovation starts. Purchase research consultant services. Yes, like we did in Deep Lab. What can you, as individuals, do about it? Be innovative, read papers, be updated with state-of-the-art research. Solve complex problems by using interdisciplinary solutions. Lecture at academic forums, courses, meetups. Be a public speaker, participate in technical conferences, publish papers or write technical blog posts, and of course open source. Very blessed initiative. If you can develop the same thing with a little more investment and publish it as an open source, it is best for the entire community. Take those guidelines and grow. That's it. Thank you.